All right, let's get into it. In game development, it's easy to get our objects moving around, spinning, and even passing right through each other like ghosts. But what happens when we want them to actually interact? Well, today we are going to tackle one of the most fundamental concepts in Unity, 2D collisions. We're going to give our game objects a sense of touch, teaching them to know the exact moment they've bumped into something else. Let's dive in. Think about this for a second. Your player character might bounce off a wall, right? And maybe your enemies can push each other around. That's all just Unity's amazing physics engine doing its thing. But here's the catch. That's all it is. Physics. Your game's logic, the part that makes decisions, has no clue any of this is happening. It's kind of like watching a silent movie crash. You see the impact, you see the chaos, but there are no real consequences. Your player can't pick up a coin because the game doesn't know they touched it. An enemy can't deal damage because the game isn't aware of the hit. We can see the crash, but the game itself doesn't know it happened. So, our goal for today is actually pretty simple, but it is incredibly powerful. We are going to write one tiny little piece of code, and this code is going to give our object a voice. It's going to let it print a message to the console the instant it collides with something. We're literally going to teach it to say, ouch. And believe me, this one skill is the foundation for almost any game mechanic you can possibly think of, from collecting items to taking damage. Okay, so our journey starts by creating the brain for this new awareness. We need to set up a dedicated C# script. This script is going to be the home for all our collision logic. It's the place where we write the instructions that tell a game object how to react when it makes contact with the world around it. Now, I know what you might be thinking. Hey, can't I just cram this code into my existing player controller script? And, well, technically, yeah, you could. But trust me, that is a road that leads to madness. As your game gets bigger and more complex, that one script would become this giant, tangled-up mess of code for movement, shooting, health, and now collisions. It becomes an absolute nightmare to read, to fix, and to manage. So here's the deal. We're going to embrace good practice from the start. We create a new, dedicated script for each separate piece of functionality. It keeps our project clean, organized, and way, way easier to work with down the line. Okay, let's actually do this step by step right inside the Unity editor. First, look for your project window. It's usually hanging out at the bottom of your screen. This is where all your game's files live. Now, to keep things tidy, I'm going to double-click my scripts folder, but you can do this right in the main assets folder if you want. Find yourself an empty bit of space, right-click, and a menu's going to pop up. From here, just hover your mouse over Create. See that other menu that flies out? Go down that list and click on C# script. And boom, a new file appears. Its name is highlighted, all ready for you to type. Let's call it Collision. With a capital C, that's just good practice, and then hit Enter. That's it. The blueprint for our new awareness now exists. All right, we've made the container. Now it's time to actually fill it with something. Let's go ahead and open up that new collision script we just made. Just double-click it. This will fire up your code editor, whether it's Visual Studio, Writer, whatever you use. And now we get to the really fun part, writing the actual code that's going to listen for a collision. So when you open a new script, Unity is nice enough to give you two default methods. Start, which runs just one time when the game begins, and Update, which runs over and over and over again every single frame. But for what we're doing today, we don't need them. Our logic doesn't need to run on a schedule. It only needs to fire at the exact moment a collision happens. This is what we call being event-based, and it is so much more efficient than constantly asking, did we hit something, every single frame inside Update. So to keep our code nice and tidy, we can just delete both of them. Just highlight everything from the start method all the way down to the closing curly brace of Update, and just hit Delete. Gives us a nice, clean slate to work with. And here it is. This is the magic phrase for today. On collision enter 2D. Now, this is not a function that we ever call ourselves. It's a special event function that's baked right into Unity. Think of it like a secret alarm system. Unity's physics engine is constantly watching all of your colliders, and the very instant it sees your object's 2D collider touch another one, it immediately scans that object's scripts, looking for a method with this exact name. If it finds one, it runs whatever code we put inside. This is our direct hotline to the physics engine. So inside our nice, clean script, just start typing on collision, and you'll see your code editor's autocomplete immediately pop up with a bunch of suggestions. Now, it's super important you pick the right one. on collision enter 2D. That 2D part is absolutely essential for 2D physics. You'll probably notice there are other options too, like on collision exit 2D and on collision stay 2D. And those are also event functions. One triggers when objects stop touching, and the other triggers for every single frame they continue to touch. But for right now, we just care about that initial contact. So we're going to select on collision enter 2D and just hit enter. And poof, the editor generates the whole method for us. This structure is the exact signature Unity is looking for. The name, the capitalization, the stuff in the parentheses, it has to match perfectly for that alarm to go off. And our code? It's going to go right between those two curly braces. Let's quickly break down what the editor just gave us. You might see the word private at the beginning. You can totally delete this to make the code look a bit cleaner. It's not going to change a thing for what we're doing. But the most important part, the really powerful part, is inside the parentheses, collision 2D other. This is a game changer. See, when the collision happens, Unity doesn't just run our code, it also passes in this little package of information all about the other thing we just hit. This variable, which we're just calling other, holds all that data. So, for example, we could write other.gameObject.name to find out the exact name of the object we ran into. This is how you can tell the difference between hitting a wall or an enemy or a power-up. We don't need it for a simple ouch message today, but just know, this little parameter is the key to creating all sorts of complex interactions later on. All right, pop quiz time. This is a little challenge for you. We've talked about this before. You now have the exact spot in your code that will only run when a collision occurs, right there between those curly braces. And you know the command to print a message to the console. So just take a second and think. What's the single line of code you'd write inside that on collision enter 2D method to make the word ouch show up in the console? And here's the answer. It's just one simple, elegant line. Debug.log ouch. We're using the log method from Unity's debug class, and we're just giving it the text we want to print wrapped up in quotation marks. And remember, every statement in C# needs to end with a semicolon, so we pop that on the end. Now, make sure you save your script file, usually Control-S or Command-S, and that's it. This single line is armed and ready to go. The moment our collision event is triggered, this code is going to run. So we've written the perfect set of instructions, our code is saved, it's sitting there patiently in our assets folder, but right now it's just a blueprint. It isn't actually attached to anything in our game world. Unity has no idea which object is supposed to be using this new brain we just built. We gotta fix that. This is a really crucial point. A script file just sitting in your project window is totally inert. It does absolutely nothing on its own. To bring it to life, you have to add it as a component to a game object that's actually in your scene. Think of it like this. Our script is a perfectly built car engine, but until you actually install that engine into the chassis of a car, that car is not going anywhere. Our script is the engine, and our player game object is the car. Okay, back in the Unity editor we go. Find your player object in the hierarchy window, and just click on it once to select it. Now look over to the inspector window on the right side of the screen. You'll see a whole list of components that are already attached to the player. You know, things like its transform, its sprite renderer, its rigid body. We need to add our new script to this list. The absolute easiest way is to just go back to your project window, find our collision script, and simply click, drag it over, and drop it anywhere onto the inspector. You'll see it pop up right at the bottom of the list. The other way to do it is to click the Add Component button at the very bottom of the inspector, type collision into the search bar, and select it from the results. Both methods do the exact same thing. Okay, quick recap. We've written the code that listens for a collision. We've attached that code as a component to our player game object. In theory, everything is wired up and ready to go. There's really only one thing left to do. Hit that big play button at the top of the editor and see what happens. And there it is. As soon as your player object bumps into another collider in your scene, you should see the message ouch just pop right up in your console window. You might need to open the console tab to see it. Go on, drive your player into a wall, another object, anything with a collider. Every single time you make contact, a new message appears. Success! Our object is now officially aware of the world around it. Now, if you keep bumping your player into things, you'll notice your console is going to fill up with ouch messages really fast. And this is where a fantastic little tool comes into play. Look at the top bar of your console window, and you'll see a button labeled Collapse. Go ahead and click it. Check that out. Now, all of those identical messages are grouped into a single line with a little counter on the side telling you how many times that collision has happened. This is so much cleaner and unbelievably useful for debugging. If you ever want to see the full messy list again, just unclick Collapse. But for frequent events like this, the Collapse feature is an absolute lifesaver. So, It works, which is awesome. But why does it work? It's not just about the script we wrote. The script is the reaction, sure, but the physics engine has a really strict set of rules that have to be met before that event is even triggered at all. And understanding these rules is going to save you so much headache when, inevitably, your collisions don't work the way you expect. So here they are, the 2 golden rules for collision events in Unity. If your collisions are ever acting weird, I can almost guarantee you've broken one of these rules. Rule number 1, both objects that are colliding must have a collider 2D component. This just makes sense, right? The collider defines the object's physical shape. If you don't have a shape, you can't collide. And rule number 2, at least one of the 2 objects must have a rigid body 2D component. This is the one that trips people up. The rigid body is what officially registers an object with the physics engine. It's what tells Unity, hey, I'm a dynamic thing that can move and be affected by physics. Without a rigid body, Unity just assumes an object is static scenery, like a wall or the floor. Even if 2 static objects with colliders touch, nothing happens, because neither of them are really in the simulation. You need at least one dynamic, rigid body-driven object to kick off the event. As long as you follow these 2 rules, your code will work every single time. So let's just take a step back and really appreciate what we've accomplished here. We started with objects that were, physically present, but were fundamentally clueless about their surroundings. And now, just by creating one simple script and understanding the core rules of Unity's physics, we've given them a sense of touch. They're no longer silent, they can react. This right here is the bedrock of interactivity in pretty much any game you can imagine. And that, my friends, brings us to the most exciting part. Printing ouch is just the very beginning. This is a gateway. Now that you have this incredible tool in your tool belt, what are you going to build with it? Instead of debug.log, you could decrease a health variable. You could destroy the other object, to simulate collecting a coin. You could play a sound effect, trigger a massive particle explosion, or open a door to the next level. The possibilities are genuinely endless, and they all start with this one simple event, on Collision Enter 2D. So, my question to you is, what will you create first?